Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be making the calculations for a resistive capacitive complex circuit from the Chapter 17 math handout, problem number 21. And in this circuit, I am given capacitance, but I'm not given capacitive reactance. So the first value we're going to calculate using formula number 9 that you see here that I've copied from the Chapter 17 formula handout. We're going to use formula number 9 to find this XC value. So we're going to do 1 over under 2 shift pi times, I need my frequency, which is 500 hertz, times my capacitance of 0.06 times 10 to the negative 6. It equals engineering, and this gives me 5.31 k ohms for my capacitive reactance. Alright, my next step, I'm going to calculate my ZT using formula number 16. So I'm going to open square root first. I'm going to punch in my resistance value of 3.01 times 10 to the third. I'm going to square that number, squared, plus my XC value of 5.31 times 10 to the third, and I'm going to square that number. It equals, hit engineering, 6.10 k ohms for my total impedance. Now that I have that done, I'm going to move to step 3, and I'm going to calculate my current values. Current's going to stay the same in a series circuit, so once I calculate my IT, I'll have all of my current values. Inside of these parentheses, we can use Ohm's law, so I take 106.25 volts and divide it by 6.10 k ohms. Gives me a value of 17.42 milliamps. As I said, current stays the same. Now I'm just going to use Ohm's law to take my IC times my XC to get my VC, my IR times my R to get my VR. Again, you cannot add VC plus VR to get VT. You have to use formula number 14 if you want to check your work. If you use this formula, the square root formula here, number 14, you should get the VT value that you were given. It's always good to check your work against a value you were given to make sure you did everything properly. So let's do that. We're going to open our square root. We're going to do VR, which is 52.43 squared plus 92.5 squared. It equals 106.33. Well, it's a little bit off, but that's okay because we're not using every single number after every decimal point in all of our calculations. So on your test, if it's a little bit off, let me know and I'll correct it for you. I'll give you credit for it if it's just a minor rounding issue like what I had here. On your homework, I would like for you to go in and correct it yourself. The homework is set to allow multiple attempts, so do your first attempt, and then if it doesn't give you the right, if it marks it wrong because of a rounding error, just redo it. Alright, next now we need to do theta z. So to do theta z, you see our formula here. The first thing we're going to do is inverse tangent, so we need to hit shift first, then tangent. We're going to hit the negative sign. We're going to put in XC of 5.31 times 10 to the third, hit over under 3.01 times 10 to the third, scroll over, close parentheses, hit equals. That gives me negative 60.45 degrees. The reason why we can't add up voltage in our capacitor and voltage in our resistor is because they're out of phase. How much are they out of phase? About 60.45 degrees out of phase. Thank you.